Please go ahead, sir. No problem, sir. No problem. Please go ahead, sir.
Okay. Should I make it full screen?
Do it, sir. Do it, sir.
Yeah.
Now it's clear, sir. Yes, sir. Full screen.
So that you can see more.
Yes, yes. Good, sir.
This topic is a general topic which I have framed based on the research experience that I have got in the academic life as well as in the real life. This is a topic which can be even understood even by non-computer science people also to greater extent. Why I actually thought of delivering a talk like this, which is like a kind of philosophy which I have put into the topic itself. So let me go with the topic, then you will understand why I am calling it a philosophical thought on searching. So let me start with the basic question, what is searching? And in fact, in the offline class, I allow the people to answer, but now it may take more time because it's very difficult. Let me come to the point. This topic, everybody knows, but to put it in a kind of a definition, maybe one find it difficult. So to make it understand and to compare with the computer science searching, so let me give you a little background. Since the beginning of mankind, the human beings, what we are in search of various things. The basic thing that everybody needs is water. You can see the symbol here. So water. Water is an essential thing for every human being. Not only human being, even for other animals, other plants also. But when we look at the history, like most of the histories that we have, very old histories like Harappa, Mohenjo-daro history, they're all like settled along the banks of rivers that shows that water is an essential mineral for all the human beings. That's why the early history started along the bank rivers. But now, of course, like place like Bangalore, even there are no rivers, there are a lot of developments because of the technology. Now, because water is actually brought to even hill stations or places like Bangalore through technology. So it is not enough. It is not enough if we have water. We need nutritious food. Nutritious food. So the human beings are also in search of nutritious food. This is how the search started with water and nutritious food. It is not enough if we have water and nutritious food. We cannot live like other animals in the forest. They also have the water. They also have the nutritious food of their choice. But we need a shelter. And we all know that there were no Taj Mahal, there were no buildings like 5,000 years back or 10,000 years back. We used to stay, the human beings used to stay in caves, then started building small huts like the one which is there in the picture. Small huts. In fact, I too, with my family, stayed around 30 years back in a farm, in a the coconut leaves hut. Of course, it was a wonderful stay. Now we don't get that much sleep when we sleep inside the concrete building. That is a different thing. But these days we cannot even stay comfortably with the huts. You know the problems. It's very difficult. So we need to have a small house like the one which is shown. Nothing wrong in having a small house or a small Taj Mahal, small palace for yourself. But the unfortunate thing, the human beings are building many Taj Mahals for next 10 generations. That is the problem. Okay. So the search does not stop there. Like water, nutritious food, huts, or building, or house, it does not stop there. So it continues. We all know that in the history, how human beings started searching for yellow metal, that is gold. And that too, girls are fond of yellow metals. At least something they should have on their face on their neck. It's not unnatural. All human beings are attracted towards yellow for two reasons: to increase the beauty, and also it is a kind of wealth that you can have. And we have also costly items like diamond, even costlier than that titanium. And all these things were actually digged out by the human beings, which were there already in the nature, but the human beings started searching for all these things. And the search does not stop there. You all know that many people are actually after dollars because they think that dollar is more stable. Like you know now, in Sri Lanka, there is a problem. The money value in Sri Lanka has gone down. Even maybe same thing in Afghanistan also. Whereas the dollar, people believe that it is more stable. And I know many of my friends, they keep instead of rupees in dollars. We also know that the story of pink notes, when it was released, 2000 rupees pink note, when it was released, the common man like you and like me, we were not able to get 1 or 2 notes in the beginning. At the same time, we used to see in the TV, we used to see in the paper how people were actually bringing bundles of 2 pink notes, keeping in toilet, keeping under the bed, and so on. That shows that the human beings are in search of many things. So the search continues like this, and so on. So if you think that the wholly human beings are in search of things like this, it is not true. Let me show you. Any living organism, any living being is in search of material of their interest, item of their interest. For example, ants, they search for their food. Honeybee, it searches for its food. Look at this fly. And if I ask you to show me some flies, you cannot. But let me tell you how you can show the flies. Go to nature call in the nature, outside, not in the toilet room. Before you get out of the nature call, you can find the flies. How they are coming? You have not invited them. Because they are already in search of their food. Somehow through smell or something, they will come to know there is a food. Your excreta is a food for them. That is why they come to your place when you go for nature call. So these are all things like the things like human beings or other animals, they can move. Whereas the plants, even though they are not able to move from place to place, they are also in search of food or things of their interest. For example, when you go for a morning walk, under the big trees, even the small plants, small creepy plants, they also look for the sunlight. In order to produce the food, they need to have sunlight. That is why you can observe that in the morning when you go for a walk, the small plants under the big tree, they also look for the search for the sunlight. The story goes like this. Now, let me come to computer science. What we mean by search in computer science? Basically, a search algorithm is an algorithm that retrieves information stored within some data structure inside the computer. A search algorithm is an algorithm for finding an item with specified properties among a collection of items. Collection of items are given. We need to find one item of interest. The items may be stored individually as records in a database. You know that a database is basically a collection of records. All the informations are stored in terms of records. Or maybe by elements of a search space defined by a mathematical formula or procedure to find such as the roots of an equation. These are all search. Now, in general, we have talent search. Like if you go for a company, they look for the talent. And many of you might have passed this time, like people look for the life partner. That is also a search. Search for precious metals. In fact, the whole history of human beings is behind search of precious metal. Search for knowledge. like why you are attending this, you need to have updated information. Search for thieves. The police people, they search for thieves. Search for jobs. Like once you complete your graduation, post-graduation, PhD, you search for jobs. Like this, it continues. Now, this is all about searching in general, in real life and so on. Let us see what are the search algorithms that we usually look into in computer science. We have 3 search algorithms which are very popular in computer science. The first algorithm is called linear search, and linear search is also used in the real life also. Like when we have unsorted items, we look for the item of interest from beginning to end to beginning, beginning to end, in whatever way. But it should be from one way to the other way. Look at this. This is an array of unsorted integers. Unsorted integers. Like 3, 15, 2, 8, and so on. Unsorted collection of items. Now, the 3 is actually, in case of mathematical notation, we say 0th location, 1st location, last one is actually n minus 1st location. You can even start with 1 to n, no problem. So, suppose this array is indicated by name A. So, I say A of 0 is 3, A of 1 is 15, and A of 11 is 5, and so on. So, whenever we search in this list, we start from the 0th location, that is A0. Now, let us see. Suppose I want to find 25. If I want to find 25, how I do it? I take 25, compare with A0, that is 3. So, 25 is not matching with 3. Then I conclude that I should go to next location. Then I compare 25 with 15. Oh, here also it's not matching. I go to next location. Like this, I continue, and you can note that 25 does not match with any item here. Last item is 5. Even that is not matching. Then I conclude that search is unsuccessful. So, what we observe here, in the worst case, I need to compare with every item to say whether the item is there or item does not exist, whether the search is successful or unsuccessful. So, this is a very specific property of linear search. You need to go from one end to the another end. In the worst case, it will take harder n comparison. Harder n means n is actually number of items in the list. We call it as input. So, in the list, here you can see there are 12 items. So, n equal to 12. 0 to 11 means 12. So, n is the input size. Number of comparisons is in comparison with input size. So, we say harder of the linear search is harder n, where n is the input size. So, you understood. Now, I remove 5 out of 25. I just remove 2. Sorry, I remove 2. I just take 5. Again, I compare 5 with 3, 5 with 15, 5 with 2, and so on, and 5 with the last 5. Oh, search is successful, but it has taken 12 comparisons. In order notation, n comparisons. Now, I remove 5, I take 2. 2 is compared with 3, 2 is compared with 15, 2 is compared with 2. Only 3 comparisons. In the best case, 1 or 2 comparisons. In the worst case, n comparisons. Even when the item is there or not, in the worst case, n comparisons. You understood? Linear search, we also apply in the real life. Everybody applies linear search, one way or the other way. Let us keep it in the stack. I go to next search. So this is called binary search. Not only computer science people, not only mathematics, statistics people, even everybody uses the binary search. This is not different from dictionary search. Binary search, in a way, is dictionary search. If you are looking for a word in a dictionary, what you do? You take the dictionary, you assume that the dictionary is sorted. All the words in a dictionary sorted from letter A to letter Z. So given a word like monkey, I want to find the meaning of monkey, its activities and so on in the dictionary. How to pronounce it, so on. I go to middle of the dictionary. Then I divide the dictionary into two parts. I see whether the monkey is in the middle or to the left or to the right. Half of the dictionary is cut off straight away. Then I go to the left if it belongs to left side. Again, in the remaining part, I divide the dictionary again into approximately 2 arms. This is exactly the binary search. And note that in the binary search, all the items should be sorted either in the ascending order or in the descending order. Look at the yellow list. It is arranged in the descending order. 9, 7, 6. So descending order. Look at the right side. That is, I think, some purple color. Where, or cement color, where we have 1, 4, 4, 7, 7, 8, 11, 19, 21, 23, 24, 30. Look at this. Here, all the items are sorted in the increasing order, ascending order. But for binary search, the list should be sorted either in the ascending order or in the descending order. Now, if you really look at the binary search, the real binary search, even if you have 1024 items, within 10 comparisons, you can search any item. Because each time you can divide the list into two parts, like 512, 512. 1024 becomes 512. Again, within 500, you can divide 256, 256, 128, 128. Then 64, 64. Like that, each time you are cutting the list, ordered list into half, approximately half. So within 10 comparisons, you can search for any item. That is the beauty of binary search. But the ugly part of the binary search, the list should be sorted always. Like if things are getting deleted and inserted, binary search may fail to give its best performance. Now, if you compare binary search with a linear search, you can insert and delete at any time in the list, but in the worst case, it takes more time. Binary search, it takes less time, but the list should be sorted. Now, there's another searching technique which is normally used in computer science. Even otherwise also you can use it in the real life, but it is not popular. In the public, if you ask some people the technique, they may say, no, I do not know about it. But we use it very, very less common in the real life, whereas the computer science people use it very often. Let us see that. That is called hashing. Now, look at the picture here. I can give you different hashing techniques. And we divide all the numbers into some slots. Each slot is called a bucket. For example, look at this. I have 8 slots, 0 to 7. 0 to 7. Given any integer, I can fit that integer into one of the 8 slots or one of the 8 buckets. For example, if you give me 13, I divide by 8. What remains as a remainder? 5. So I will go to 5th bucket. So 13 will go to 5th bucket. For example, 72. Divide 72 by 8. The remainder is 0. It goes to 0th slot, 0th bucket. Like this, any given number, you can put them into slot. And if there are multiple, for example, 80 will also come to 0th slot. 72 will also come to 0th slot. 8 will also come to 0th slot. 16 will also come to 0th slot. I will make a chain within that bucket. Now, I give another example where we can use effectively. You know, all the names, they start with a letter. For example, Suresha, it starts with S. Asha, it starts with A. Now, given all these names, I can make 24 slots or 24 buckets. just based on the first letter. So it's very easy. Now, all the letters with all the names with letter A, I will put them into A bucket. All the letters with B, I will put them into B bucket. For example, Bhaskar will go to B bucket. Umesh will go to U bucket. Jinxie will go to Z bucket. Timmappa will go to T bucket, like this. So, why we are doing this? How much time it takes? Where it is useful? That beauty of the hashing we should know. Hashing will take very less time, but where it is applicable. Hashing is not very commonly used in the real life, whereas in the computer we use extensively. Let us see the place. You all might have written some small programs, C program, C++ program, Java program, computer program you might have written in various languages. All these languages, in all these languages, we use names for representing the variable, representing something, maybe a string or a number or a record and so on. These are called identifier. Names are called identifiers in any programming language. Now, you take any program and look at the actual identifiers that you use are very small. For example, for calculating the area of a triangle, calculating the area of a circle, we need 3-4 variables, not more than that. So, but how many such names are possible? Like, look at the names in the world. How many names are there? In the world, we know that there are approximately 500 to 600 crore people. Approximately, we may get some 40 to 50 crore names. But in a classroom, how many students are there? How many names are there? 30 students. I think in this class, 35. So, actual number of names are very high. We call it as identifier space. All possible names are very high, but actually used very small. So, when we translate a computer program into machine code, we use what are known as symbol table while translating a source program to machine program by a software called compiler. So, there we use this hashing techniques extensively. But in the real life, we do not use it too much. Now, I covered 3 searching techniques: linear search, binary search, hashing or hash search. So you remember, in computer we use only 3 search: linear search, binary search, hashing. Now, I bring some problem which you have faced in your real life. Maybe in the future you will face the problem, or you look at the other friends who are also having this problem. It is common. This problem is not a new problem. Let me tell you how old it is. Look at this problem. If you are searching for a life partner, I mean for a bride or a groom, boy or a girl, as your life partner, tell me which algorithm you can use. We have only 3 algorithms now: linear search, binary search, hashing. To get the life partner, which searching technique you can use? It's a very wonderful problem. And how old the problem is? I can give you some examples. In Ramayana, father of Sita, that Janaka, wanted to get a best boy for Sita, that Rama. So he arranged what is known as Swayamvar, a marriage competition, to get a better boy for Sita. At least I can say this problem is so many years old. As the age of Ramayana, maybe 5,000. People say that it is around 10,000 years back. I do not have the proof. Approximately, people say that Ramayana 10,000 years back and Mahabharata approximately 5,000 years back. That means this problem was there also. Now tell me which algorithm you can use. Anyone can tell. to get the life partner, which searching technique we can use. And you might have faced this problem. This problem is a very common problem in everybody's life. Okay? Now let me tell you, this is a one such problem no computer can solve forever. It is my gut challenge. I am a computer science person, but that doesn't mean that we can solve all the problems by computer. There are dozens of problems, hundreds of problems, very interesting problems computer can never solve. This is one such problem. In fact, computer can solve a problem provided the problem is well defined. The criteria are clear. In the case of searching for a life partner, criteria is not well defined. Like when you go and look for a girl or a boy, certain things you hide. You do not express. So if you cannot express the criteria, how a computer can understand? And which algorithm you can use? What is the input size? So let me tell you, no linear search, no binary search, no hashing can be used. And how this problem is solved in everybody's life? So if you really look at, randomly you do not know. Somebody comes and tells you, there is a very good boy there, very good girl there. By hiding some bad things they tell you. Because we all know that ಸಾವಿರ ಸುಳ್ಳು ಹೇಳಿ ಒಂದು ಮದುವೆ ಮಾಡು. By 1,000 lies, you can arrange a marriage. Nothing wrong with that. So this is not even random search. According to me, with my observation, I can say it is a lucky search. If you are lucky, you get a good life partner. If you are unlucky, you know what it will be. So this is one such problem which can never be solved by any computer. However, the computer intelligent or fast, whatever, this is a problem which will be there forever, which cannot be solved by computer. So we should also understand that there are limitations of any machine. You should not expect that everything can be solved by the computer. Now, coming back to computer science. So, in the real life, we have two things. One is exact search and approximate search. Exact search and approximate search. In computer also, we have exact search versus approximate search. But the difference will be totally opposite between the computer and the real life. Let me show you. Look at these pictures. Look at the first picture and look at the second picture. The first picture you say, oh, good couple, perfect match. And the second one you say, oh, it is not perfect. Oh, the girl is very big, very fatty. The boy is very small. But do you know that in the real life, most of you have experienced the exact search does not work. One way or the other way, there will be differences. Whereas in the real life, even if there are differences, you accept it and proceed. You can never look for perfect match. So it is easy in the real life for imperfect match. Whereas in the computer, perfect match is easy, but approximation is difficult. So in the real life, approximation is easy, perfect is difficult. In computer, perfect is easy, approximation is difficult. Difficult in the sense, it takes more time, more storage. So we should know even this difference. Now, with all this, back to the basic definition of what is computer science. What is computer science? It is not difficult at all. It's a very, only 3 words. Study of algorithms. That's all. Study of algorithms. What is an algorithm? It's nothing more than a procedure. For every work, we have a procedure. For example, if you want to make uppittu, upuma, we have a procedure. If you want to make dosa, we have a procedure. Even to make coffee, tea, we have a procedure. If you do not follow the procedure, then you won't get even tea, coffee also. For example, when you want to make the tea, first you have to boil the water, put the tea powder, maybe put the milk, then add the sugar and so on. If you reverse the thing, what will happen? If I put the sugar first and boil it, if I put the tea powder first and boil it, then add the milk, boil it, then put the water. Will you get the tea? No. We need to first boil the water. That means for every work, we have a procedure. A procedure or a method to carry out a work is called an algorithm. Nothing more than that. An algorithm means a method or a procedure. So, in a procedure, we have a set of actions. An algorithm is nothing but a step-by-step procedure or step-by-step actions to carry out a particular task. That's all. I think you understood. An algorithm is a step-by-step actions to carry out any particular task. Nothing more than that. Now, when we have an algorithm, we have something called data structure associated with it. It is something like to get a child, whether male is important, female is important in the real life. In the real life, male is important, female is important, or both are important. Now we all know that olden days gone. We all say that both male and female, man and woman, both are required. To have a wonderful life in the nature, we need both male and female. You cannot say who is greater. They are equally important. Similarly, when we want to really write a program, there are two components in it. Any program you take, any program, there are two components in it. One component is called algorithm, that is nothing but procedure. The another component is called data structure. Both are important. Data structures without algorithms, useless. Algorithm you cannot write without data structure. And put together, nothing but program. In fact, if you go to market, there is a wonderful book you buy, it is very cheap, maybe 200, 300 rupees. A book written by a person called Nicholas Wirth. Nicholas Wirth has written this book like a formula, algorithm plus data structures equal to program. If you read that book, you will understand the complete manipulation of how we carry out the programs or actions to do any particular task in a computer. And he is the man who designed a language called Pascal. Nicholas Wirth has written a language called Pascal in memory of a mathematician, Blaise Pascal. Blaise Pascal did not write the Pascal language. He was a mathematician. Because of his contribution, Nicholas Wirth actually named that language as Pascal. Okay, that is the story. Now, what we have to understand in computer science, only two words. If you know these two words, you know computer science. That is the idea. But even to know these things, our entire life is not sufficient, that you will understand. What are the things that we should know? Algorithm and data structure. Okay. What is a data structure? What is a data structure? It is nothing more than a specialized format for organizing and storing data inside the computer main memory. You remember that? There are two memories. Even with the human being same, we have two memory. The memory which we have inside the head, that is volatile in nature. That is the reason why we ask for PPTs, why we ask for notes, why we write down the notes. Because we cannot remember everything. We write down on a piece of paper. Now, which is volatile, which is not volatile. Anything that we take inside our memory is volatile. Over a period of time, you forget. Whereas anything written on the paper, it is non-volatile. You can keep it for long time. Very long time you can keep it. So, any information stored inside the computer main memory is volatile in nature. The moment you remove the power, whatever information stored disappears. That is the reason we also store the information on secondary storages like pen drive, floppy disk, magnetic disk, or magnetic tape, and so on. So they are called secondary storage. And even there also we have structures, but they are not called data structures. They are called file structures. So remember that data structure means arrangement of data in a specialized format inside the computer main memory. Whereas the same thing on a secondary storage is called file structure. Data structure means computer main memory. File structure means secondary storage. So I will not go into secondary storage. I will continue with the data structure. Now, in computer science, there are only two things: algorithm, data structure. So you understood what is data structure. We have various data structures like stack, queue, array, linked list, B tree, B plus tree, and so on. Okay. So I am not going into that part because my idea is to show you the searching. What is searching and why it is so important? I have to come back to searching. Now, one side we have data structures. The other side we have operations on the data structures. Operations on the data structures. Any data structure you take, it has one or more operations on it. Otherwise, it is useless. Otherwise, it is useless. And on any data structure, we may have some of the operations which are mentioned here. One is traversing, another is searching, another is inserting, another is deleting. Note that these are the four important operations we apply on the data structure: traversing, searching, inserting, deleting. Occasionally, very less frequently, we have sorting and merging, but they are not independent. They are also a manipulation of the operations which are given above. That is traversing, searching, inserting, deleting. So I will not discuss about sorting and merging because they are not independent. I come back to the four basic operations that we use on data structures. Because I want to show you something interesting here. Okay. Now, what is traversing? What is traversing? How it is different from searching? So I give multiple examples so that you can understand. Given a list of items, or an array of numbers, an array of records, a collection of items, processing every item exactly once. Processing every item exactly once is called traversing. So where we see this kind of traversing in the real life, let me give you some examples. If you go to any mutt, like Gadapati Sachidananda Mutt, JSS Mutt, or this our Siddhganga Mutt, or any other mutt, Adi Chunchanagiri Mutt, if you go and wait in a queue for a blessing of the saint, ಆ ಮಠಾಧಿಪತಿಗಳು ನಿಮಗೆ ಆಶೀರ್ವಾದ ಮಾಡಬೇಕು ಅಂದ್ರೆ ನೀವು ಒಂದು ಕ್ಯೂ ಅಲ್ಲಿ ನಿಂತ್ಕೋಬೇಕು. That is the usual thing. When you are standing in the queue, that saint will bless you, maybe touching your head with his hand. So if he is impartial, unbiased, then he has to give the Ashirwad by touching your head with his hand exactly once. If somebody is ugly, he cannot reject because he is the head of the mutt. He has to touch everybody exactly once. That is actually nothing but traversing. Or I give another example, which is a very wonderful example. There is in South India, there is a very famous lady, that is Amrutanandamayi. Amrutanandamayi is another saint. Her way of blessing is different. Everybody knows, I think, we have gone to her mutt, or we have taken the blessing. Out of 35, some of you might have taken a blessing. I heard that every bhakta, devotee, is hugged by her. She is going to hug you so that you get the blessing. That's a different method of blessing. Now, look at this scene. If there is a huge queue, 100 people standing in the queue, she is hugging everybody exactly once. She cannot reject somebody. Oh, you're not a handsome man. I cannot hug you. Can she say that? Whether man is handsome or ugly, she has to hug exactly once. Suppose that somebody is very handsome, she cannot hug twice because others are looking at. So this is a very good example in the real life. When you go to Amruta Mutt, you can observe this. Every devotee will be hugged by Amrutanandamayi exactly once. This is called traversing. Now, let me come to searching. So, the searching and traversing are different. Now, you take the linear list. Suppose you are searching for an item which is there in the first position. You stop there because search is successful. Like when the police people in a village, if a thief, they go and search in the first house. Based on some inputs. Hello? Hello? Somebody is asking?
Hello?
Any question?
No?
Sir, I didn't understand. Hello, I didn't understand what I was. I have a question.
I think some audio problem.
Hello.
I'm not able to hear you. Am I audible? Hello?
Hello.
Am I audible?
Hello.
Hello? Am I audible?
Yes, sir. Yes, sir.
Sir, now hearing me? Yeah, now.
Some disturbance is there.
I think disturbance is there. Fine. Maybe at the end they can ask me. Okay. Now, when you are searching in a linear list, if the item is at the middle, in the first position, you stop the search there. In the middle, you stop the search there. In the worst case, you go to end. Now, if a police is actually searching for a thief, you will go to first house, second house. If the thief is caught, you will stop there. Now, look at the linear search. In the worst case, what? In the worst case, we compare with every item. We compare with every item exactly once. And we go up to the last item. Now, if you look at the worst case is one case which is exactly same as traversing. The worst case of searching is exactly same as traversing. That means traversing is a special case of searching. It is not independent. It is a special case of searching. Now come to insertion. You take a binary list which is sorted. If you want to insert another item into that, you need to find the position first. You need to find the position first where you can insert a new item without disturbing the sortedness. That means first you are searching for the location, then insertion will be easy. Again, if you want to delete an item, first you search which item to delete, which location item is there. Then you can delete it. Deletion is easy. Again, you have to do that. Okay?
Sir, are you hearing me, sir, now?
Hello?
Now are you hearing me, sir?
Yeah, somewhat. Tell me. Tell me what is the problem?
You have explained about traversing. I didn't understand what is traversing exactly. Can you give the example with not taking computer science example itself or search example itself, not taking the example of Mutt and Swamiji?
Yeah, you take this, you take anywhere, like when you go and ask for the prasad, you know, in a temple, if you go and ask for the prasad, If you are in a queue, hello, can you hear me?
Sir, your voice is very much audible to every one of us. You
I
can
do
go
not.
ahead, sir.
That particular person is having a problem.
Yeah.
Now, I tell you the case. There are plenty of cases in our real life, plenty of real life cases where we have a operation similar to traversing. Like when you go to some ration shop, if 100 people are standing in the queue, some items are given, same amount of items are given to everybody. Only once, unbiased case I'm talking. Some items are given, like prasad given in a temple, everybody, maybe 1 spoon of prasad to everybody. Or when Asirvad is given by a saint to everybody, touching exactly once. So they're all real life examples where all the items in the list are processed exactly once. Okay, I give another example which is very common. And every 6 months we observe this. In an organization like Government of Karnataka, when DA is given, every 6 months once DA is given. I hope you know this. Dearness allowance is given every 6 months. Suppose last time it was 11% given. Now that has to be applied to all the employees exactly once. Not that you cannot give 2 times to one employee, no time to another employee. Everybody should be given same DA. That is processing every employee record exactly once. Processing every record exactly once. We have plenty of such examples in the real life. Not one. I can name 100 such examples. Like when a grace marks is given, in a competitive exam, because of some reason, like case set, there were 2 wrong choice, grace marks given, but not to one student. All the students who appeared, for question number 13, grace marks. So there also it is like touching every item in the list exactly once. Now I come back to mathematics now. Mathematics, very simple thing that everybody does in the real life. All of you know there are 4 arithmetic operators. Every day you are using this. Let me tell you what are those operators. Plus, minus, star, slash. Or in other words, addition, subtraction, multiplication, division. Every day from morning to evening, we do the same thing. Adding something, subtracting something, multiplying something, dividing something. This is how our real life is going on. Now my question is, among these 4 operations, among these 4 arithmetic operations, which is fundamental or which are fundamental? ನಿಮಗೆಲ್ಲ ಕನ್ನಡ ಅರ್ಥ ಆಗ್ತದೆ ಅಂದ್ರೆ ನಾವು ಪ್ರತಿನಿತ್ಯ 4 ಆಪರೇಟರ್ಗಳನ್ನು ಉಪಯೋಗಿಸ್ತೀವಿ, ಅರ್ಥಮೆಟಿಕ್ ಆಪರೇಟರ್ಗಳನ್ನ ಲೆಕ್ಕಾಚಾರ ಮಾಡಕ್ಕೆ. ಕೂಡುವುದು, ಕಳೆಯುವುದು, ಗುಣಾಕಾರ, ಭಾಗಾಕಾರ. ಕೂಡುವುದು, ಕಳೆಯುವುದು, ಗುಣಾಕಾರ, ಭಾಗಾಕಾರ. Addition, subtraction, multiplication, division. Among these 4 operations, which one is or which are fundamental? Fundamental ಅಂತಂದ್ರೆ ಅದನ್ನ ಯಾವುದರಿಂದ ರಿಪ್ಲೇಸ್ ಮಾಡಕ್ ಆಗೋದಿಲ್ಲ. Even when I have delivered the talk, even mathematics people, when they attend this class, they say sometimes all 4. Sometimes people say addition and subtraction. Let me tell you, only one operator is fundamental. That is addition. Only addition is fundamental. What is subtraction? Adding a negative quantity. What is multiplication? Repetitive addition. For example, 4 into 5. What is the meaning of 4 into 5? Add 4 to itself 5 times. Add 4 to itself 5 times. 4 plus 4, 8. 8 plus 4, 12. 12 plus 4, 16. 16 plus 4, 20. 5 times I added 4 to itself. Repetitive addition. Similarly, the division is nothing but repetitive subtraction. You got it? So even though we have 4 operators in the arithmetic, only plus is the basic or fundamental operator. Similarly, my idea is to prove that this you won't get in any textbook. Even though there are 4 operations like traversing, searching, insertion, deletion in computer science, only search is the fundamental. Everywhere search plays a role. So this is the whole idea of telling why searching. Why searching is so important in the real life, in computer science also. So according to me, like arithmetic operator, like plus is the fundamental, I say among all operations on the data structure, searching is the fundamental. That is my claim. So which operation is most important? There is nothing but searching. Now, I'm coming back to the research contribution in the search area we have carried out along with my students. Now I am coming to the internet and a search engine. So internet is nothing but network of networks, all put together is internet. Whatever we have on the earth is internet. Now in the internet, every day, morning to evening, even in your mobile also, you are searching. Nothing more than that. You search. Morning to evening, search. But 99.9% or even more than that, of course, it cannot be more than 100%. More than 99.9%, what kind of search you do is called text search. You type something, Mysore Palace, it will give you the history of Mysore, beauty of Mysore, and so on. University of Mysore, you type University of Mysore. Whatever you type is called text. The search is called text search. Have you ever seen, you can also search by image? The Google or any search engine you take, we have Alta Vista, we have Yahoo search engine, and we have many search engines, but Google is very, very popular. In Google also, you can input the image. For example, you can input your photo. You can take the photo and you can input into Google. Then Google will search all the photos across the globe, universe across the globe, and it will bring all those photos which are similar to your photo. You can try now. You can input your photo, you can try. Not only that, you can even input video, a clip of a video, a movie, a clip of a movie you can input, and you can get all the videos across the globe which are containing this clip. Even the audio also, like very popular song is there. Ettana Mamara, Ettana Kogile, Yeni Sambandha. It's a very popular song in Kannada, very old song. Now you do not know the history, you do not know the creator. You can sing that song, you can actually input into Google, you can get the related songs. So there are 4 different ways of searching, and in that image search engine, we have carried out a very extensive work, and 1 PhD has been awarded under my guidance in image search engine. Let us see what is an image. Image is nothing more than an object or a replica of an object, either by a camera or by an artist, or even when you stand in front of a mirror and so on. It is a replica of a real object. So, why image is so important? Let us look at one example. At the bottom, there is an image. Look at the image and tell me, what is your opinion? I asked this question to many people. Same image, I asked to many people. And the way they describe, totally different. If you give it to old people, they say the tree is very old, or in the winter season, all the leaves are falling down because the old people are almost close to falling. And you give the same image to youngsters, 20, 25 years. They say, oh, what a beautiful love symbol. See, same thing, beautiful love symbol, the same. And you look at the ground covered with red leaves, which are fallen from the tree, like a red carpet. There are so many things in the picture. A picture, why it is so important, you can see from the next slide. There are two things. The right side, text material. The left side, an image. Nothing more than an image, cone ice cream. When this image is shown to even kids, what will start coming out of their mouth? They understand it is an ice cream. Whereas in the text, we need to understand, we need to study. Even then, we cannot clearly understand it is talking about ice cream. You have both the pictures. One is text, another is real picture. Ice cream. This is story about ice cream, that's all. Which one is more attractive? The picture is more attractive. The image is more attractive compared to the text. That is why we say a picture is worth more than 1,000 words. Instead of 1,000 words, I can give a picture or an image. So I give a couple of examples so you can understand how images speak. Look at this wonderful image. It is an highway in a desert, like Sahara desert. There is one small tree and an animal, maybe a donkey, standing under the tree. In Mysore, Bangalore, places like Mysore, Bangalore, we may cut some hundreds of trees to make the roads. But in a desert, even a tree is important. So at the cost of deviating the highway, the tree is protected. Look at this. Now, I show you another picture. In Taliban, in Afghanistan, some war is going on in Afghanistan. And maybe this is similar to what they are facing now. A mother is trying to protect her baby, whereas the soldiers are trying to win the war. And we can understand a lot of things out of it. Similarly, look at this. A bird is taking care of chicks. This is a mother love, mother care. So no need to explain. So, okay. What was the reason for doing a research on image search? In fact, let me tell you, nearly 20 years back, there were no image search engines. Search engines started, of course, after 1990. By the 1995 or 2000, there were a lot of search engines. They were all text search engine. Like we used to type some information and we used to get the related information from the web. But there were no image search engine. There were no image search engine. So when I was doing my PhD in IISc Bangalore, I collected some images from the internet. One such image I inserted in my PPT. My advisor asked me, from where you got this picture? It was basically a graph. I told from the internet. Then give the URL. To thank them, give the URL. Give the reference. But I forgotten how I got the picture. I started searching. There was no way to get. Then I decided, why we should not put the image itself and get the URL. Now it is possible. You try, you can get the URL. Take the Mysore Palace from internet, put it as an input, you will get the URL. So that is actually basically a reverse search. You give the input as an image and you get the output URL. So again, when we are actually searching for the images, there are two types of search. One is called text-based image retrieval and another is called content-based image retrieval. What is the meaning of this? Like in the Google bar, if you type Mysore Palace, that is actually you are searching for Mysore Palace as image. but you are typing as text. That is called text-based image retrieval, TBIR system. Now, you need not even type. If you have the Mysore Palace image, you put it into the Google bar. That is called content-based image retrieval, CBIR. What we have carried out is actually CBIR. Earlier, whatever existing was TBIR, text-based. So, there are two types of image search. One is text-based, another is content-based. So now, in the text-based, you have to type the text so that appropriate text so that you get the image. It's very difficult. Even when you type Mysore Palace, you may not get the picture of Mysore Palace. You may get some story about Mysore Palace. It's very difficult to exactly type in the text. And whoever writes the story about the image, he should be an expert to write the story, especially in the biological system. If there are plants, only authorized people can write the text about the image. That is very, very difficult in the use web. So there are many disadvantages with the text-based image retrieval. To overcome that, we have actually worked on content-based. So let us see the disadvantage. Some disadvantage. Minimum human interaction is necessary for annotating the images. Like image is not enough. We have to write the text around the image. Annotation may be inaccurate due to lack of subjectivity of human perception. So the annotation will be based on the understanding by that person. So that may not be accurate. And also it is time consuming and laborious. Like a picture is given. If I ask you to write the story about it, let me tell you, if I give the ice cream cone, the picture, if I ask 35 people to write about it, there will be 35 different annotations. You can try this. I always do this in the classroom. I give a picture, ask them to write a story about it. All stories will be different. That means that human interaction and understanding the subject is very, very difficult. It varies from person to perception. So person to person based on the perception of the person. So that is the challenge. Now, to overcome this CBIR, content-based image retrieval introduced, we worked nearly for 4 to 5 years, and one PhD produced on that, on the content-based image retrieval system, where we input the image itself. So before that, let me tell you what is a search engine. Basically, a program that searches for items of interest in the internet. That is called a search engine. It is basically a software. We have many search engines. Popular one is Google. Okay. Many people have a misunderstanding of search engine. Let me clear that doubt. When I ask many people, they say, sir, whatever question you ask, the computer will give you, the internet will give you, search engine will give you answer. Is it right? Can you ask the question to search engine or your Google? Have you ever tried? Sometimes you are getting the answer. That's why you get confused. And note that no search engine is a question answering system. It should be very clear. You cannot ask the question to the search engine. You simply input some words. You expect what you get. A story about that. A web page about that. Multiple web pages about that. Based on the input keywords that you give. Now, I give an example. You can try. You can try this, a very popular question. You know, in Krishna Devaraya time, Tenali Ramakrishna was a very famous person. in the dynasty of Krishnadevaraya, in the kingdom of Krishnadevaraya, Tenali Rama was a wonderful and knowledgeable person, highly intelligent person, and he used to answer many questions in a way it was very difficult to expect from others. One such question was asked by some people. Vijayanagarದಲ್ಲಿ ಎಷ್ಟು ಕಾಗೆಗಳಿವೆ? How many crows are there in Vijayanagar? How many crows are there in Mysore? ಮೈಸೂರಿನಲ್ಲಿ ಎಷ್ಟು ಕಾಗೆಗಳಿವೆ? So he gave a wonderful answer, giving some number.
Hello, sir.
Hello. I think it is a very popular question.
Sir, this.
Yeah, and Tenali Rama answered very intelligently. Like, if you ask the question, how many crows are there in Mysore? Answer can be like 1,24,452. So such answer he gave. Any number that he could get, he gave. And he justified also. Now my question is, can you ask the same question to Google and ask, how many crows are there in Mysore? Will you get the answer? You ask a human being, an intelligent human being like Akbar, Birbal or Tenali Ramakrishna, or any intelligent person like you can answer.
Hello, sir.
Hello? Hello, tell me. Can you hear me?
Sir, I have a question.
I
have a question.
Yeah, tell me.
My question is, can anybody tell that how many crows are there in Mysore? Even computer, not human also, cannot exactly tell how many crows are there in Mysore.
Yeah, this is exactly.
But in computer, with semantic searching and
no.
Identify, we can say.
No. What I'm saying, Google or any search engine cannot be used for answering a question.
When Tenali Rama was born, we can get.
Yeah. See,
this question
cannot answer this.
Possible for humans also.
Cannot answer this. I know that. What I'm saying, people have a misunderstanding. Google or any search engine, you can ask the question and get the answer. That is not correct. You can only input the words like how many crows are there in Mysore. These are all input words we say. You get some answer. That is nothing but story, but not a perfect number or not a number which is intelligent enough. So any question you take and ask in the Google, it will give you something that may not be answer to your question. So what we get, some web pages containing those words, containing these words. So we should know about it. That is the limitation of any search engine. I will come to that at the end.
Sir,
hello? I'm not.
With semantic search and all, now we can, annotate.
No, I will come to maybe after covering little more, I will answer your
question.
Sir,
I will ask my questions at the end.
Yeah, you just write down the questions so that I can answer.
Oh.
Yeah.
Sir, it's already 3:10, sir.
Because I can cover little more, then I will stop, give sufficient time to you. Okay. Now, when we get the, like in the Google text typing box, you type something. You type something like University of Mysore, Computer Science Department. You get some answer. And if you really look at, there will be 10 links. In the Google, in the browser, you will get some 10 links. Okay, as the reply to your words. Then when you click on one of the links, you get the corresponding page. Sometimes you don't get the content properly. Have you observed it? You get some junk characters on the screen. It is because whatever the input that you get from the search engine is written in a language called, it's not a language, it is a display language called HTML. So there will be some tags. Around the text, there will be tags. Based on the tags, the HTML browser will display. Your browser will display based on the tags. But sometimes you get junk characters. let me tell you, the philosophy is similar to classroom teaching. When I teach, can I expect all the students to understand 100%? Highly impossible. But in spite of that, you continue understanding. In between, there will be gaps. So browser has a similar philosophy. So whatever it understands, it displays. Whatever it cannot, you will get some junk characters on the screen. That also we should know.
Sir, it's already 3:13, sir. 2 minutes more, I think.
Okay, okay. Now let me stop here.
Yes, sir. Let us have
With one
discussion.
example, I will stop. With one example, I will stop.
Yes, sir.
One day I had a problem in the real life. I had 5 acres of lemon, and one creature was actually giving me trouble. One insect was actually giving me trouble. That example is a very good example. I will show you. Look at this. These are wonderful pictures. Have you seen this?
Yes, sir. Yes, sir.
Where you have seen? Only on particular type of plants you find. And do you know the name of this insect? Okay, let me tell you. On the lemon, I observed, but this you can observe on the curry patta, curry leaves, curry bevu. That is one plant you can observe.
And even lemon tree.
Even the lemon tree.
Yes, sir, definitely.
Actually, 3 months I spent to know the name of this pest. And the entire my 5 acres of lemon garden was spoiled by this creature. After 3 months, I got it. The name of this creature is lemon caterpillar. So why I am telling you this? Even if you know search, but the more you search, you become an expert. So even though I have guided one PhD in the image search engine, to know the name of this creature, initially I spent 3 months. So that's why it is not only using the search engine, you should also have some intelligent way of putting the words into Google bar. And if you Google more and more, you will become more and more experienced. Okay, let me stop here because this story continues how we have done the image search engine. And now I allow you people to, this is actually overall picture where we have carried out the research. This picture is enough to explain the research work we have carried out. What we have done here, offline we collect all the images and the URL. Online, whenever there is a query, based on the image input query, we actually supply the URLs. That is the idea. Okay. Some people wanted to ask me questions. Go ahead. Hello?
Hello,
Please,
sir.
if you have any queries, please go ahead.
Yeah. You please go ahead.
Hello.
Hello?
Hello.
Tell me.
Hello. Sir, while you were speaking, you just said that we should be intelligent in inputting the search query to the Google or any search engine. But nowadays, with natural language processing and all.
No. Instead of saying intelligent, I should say in an experienced way you should input. So that like what words you should input so that you get the answer that you expect. You cannot ask a question to the Google.
Sir, with natural language processing.
Hello?
No. Nowadays we can ask questions.
No,
Sir, nowadays we can ask questions.
No. Let me tell you. There are special parts of search engine.
Google itself is now natural language processing search engine.
Yeah. See, the basic philosophy is not that. The basic philosophy is only to display the web pages containing the input words. But it has become so intelligent, and there are many places where you can ask the question and get some answer. But basic idea is not that. That's what I am going to say. I know that. We also asked the question. I also asked the question.
Over the period of time, they have improved.
Over a period of time, they have improved. That's exactly what I want to say. Like, if there are some particular questions, if you ask, you will not get the answer. You try that. You can ask the question like this. like whether boiled rice is good for diabetic, whether mango fruit is good for diabetic. You can ask this. The answer will not be like something like yes or no. It will give a story. You should eat this much, you should eat that much. There are some questions, if you ask, it will not give the answer, it will give a list of pages. You have to make out from the pages. But over a period of time, the search engines have improved so much, certain questions you can ask in a limited sense. Okay. But it is not a totally question answering system that we should have in our mind. And like for everything, we can ask the question and get the answer. It is not true.
Thank you, sir.
Like one question I give you. I give you one question. There are various bitwise operators. In computer science, we use bitwise operator. AND bitwise, OR bitwise, XOR bitwise, complement bitwise. Then my question is, among the following, I give 4 options. AND, OR, XOR, complement. These are the operators. Among the following, which one cannot be used to just decide whether given integer is odd or even? If I ask this question, let me tell you, you will not get the answer. If a person is sitting, an expert is sitting, he can give the answer. You got it? So inside the search engine, the experts are not sitting. They are tuned. They are developed to such an extent, some questions can be answered. Not all questions. Okay. Any other question?
I have another question.
Yeah.
I have another question, sir.
Yeah, you ask me. I will try
you
to
have mentioned the
answer as
content-based
I
image
know.
retrieval system.
Hello?
Okay, sir. Sir, you have mentioned that there is a text-based image retrieval system and content-based image retrieval system. Can you give me any example on the web that I can search, not inputting an image itself?
In the
okay,
Google,
not text, an image in it.
In the Google, there are 4 options. You have not tried, I know that. Google, you go to Google text.
No, image search option I have seen.
No, in the Google, you go to text and you look at the side, there will be other options. There will be other options. You need not type like Mysore Palace, you need not type. It will ask. Side by you look at. There will be image search also where you can input the image also. Another search engine, Tiny Eye. You can write down Tiny Eye. TINY. EYE. Tiny Eye is another image search engine. Even Google is also image search engine part is there. In the same Google, you can try. There are 4 different ways of inputting the queries. One is text, another is actually image itself like that, or you can take a photo and you can put, or from the folder that you have, from there also you can input. There are 4 different ways you can try. And in fact, let me tell you, this is a very wonderful thing, this searching. And what is